have a microphone and a pointer. Okay. So when you start, your first slide should appear automatically. Our slide. Of your presentation. Yeah. So we have to do it. Make sure we do it in the correct order because they're going to do the. And then. Is it open? And then it comes. They control it from the mixing. No, they control it from the mixing. Oh, okay. And then you have 3 slides. So just when you want to move to the second or third. Is that clear?
Simon. Introducing them, yeah? So you will say their name and the affiliation also? Because somebody, he was asking, do I need to present myself? No, there is a presenter, so... Eduardo?
It should come up on the screen.
Okay, your name and affiliation should come up on the screen.
Are you going to present briefly?
What we won't say is the title of the... We won't say the title of the project.
No, I wasn't. No, I wrote dates last night, so I have to say that.
And then you'll...
How long is it?
Simon, do not give this microphone to anybody. It's just yours. Don't change it back. Nobody.
That's for the presenter. Ok, quindi abbiamo lei, manca la francese. Allora, abbiamo Geraldine, Edoardo, Simone.
Okay, everyone, it's poster pitch time. Okay, perhaps you'd like to gather round. We're going to hear from some of the young researchers whose work you're looking at the moment around the exhibition area. So, we've got dozens of posters showcasing research projects from all over the world. They're divided into themes that correspond to the themes of the conference. So you can see environment, nutrition, biological hazards, human health, etc. We're going to have a bit of, we thought we'd try and liven things up a little bit. So each evening of the conference, so tonight, tomorrow and Thursday, we have half an hour where we're going to hear around about a total of 20 young researchers are going to come up here and they're going to pitch to you and to people who might be watching on Twitter, because we've got a live Twitter feed for this. They're going to pitch to you and they're going to tell you why their research project is important and relevant, and also why you might want to vote for their poster or any of the other posters that you see around the room by using the, I'm pointing at my pocket because that's where my phone is, by using the voting buttons on the app. You go to the menu, on the menu you'll see poster session, you see the abstracts from all the posters, and you can vote for the one that you like the best. The poster that gets the most votes wins a prize, which will be presented on Friday morning. So, we're going to start now. We have all our presenters here. You've got 3 minutes each. 3 minutes to tell these people why your research project is brilliant. And first up is Geraldine Bouet from the National Institute of Agricultural Research in France. We're not going to repeat the titles of all the projects ourselves because we'll be here for another hour and a half. Geraldine will tell you what her project is and in 3 minutes explain to you the ins and outs and the details. So please welcome Geraldine Bouet.
So thank you, that's fantastic event. So food risk benefit assessment. Why do we need this approach? Food is a basic necessity during the whole life, but it is also a fantastic topic of research. In nutrition, they look for the specific requirements in terms of macro and micronutrients, because any deficiency of excess can be associated with adverse health effects. But at the same time, they found that some optimized diet or consumption of certain food can be associated with benefits. In this same food, in terms of toxicology, some chemicals can be introduced or created during the farm-to-fork process, leading to some risk. And in terms of microbiology, we can find some pathogen, virus, bacteria, but also some pre or probiotic associated with benefits. We also have some interactions. For instance, the addition of preservative to food can increase the toxicological risk, but decrease the microbiological risk. Now, what about product formulation, process optimization in industry, dietary recommendation, cooking practices? We have a lot of creation that are very multidisciplinary. So the objective of my PhD that is introduced in this poster was to develop a conceptual and methodological framework to assess quantitatively the overall impact of food consumed on human health, including microbiological, chemical, and nutritional effects. I first look at what has been done before in risk-benefit assessment. I focus on one precise case study, infant milk diet, and I look for what has the beneficial and adverse health effects. I developed a first model including one factor per discipline, and I reused this model for a second one. Now, the main lesson learned from this project were this one, and I will focus on this one on the poster, how to carry out a multidisciplinary risk-benefit assessment. And we developed this scheme, which is a step-by-step approach that I can detail more into the poster. Now, how to compare the different health impact? We found three different ways of doing, but it's not really an easy task because, in fact, we have different kind of exposure that could be acute or chronic and occurring during a certain period of life, and they are related with different health effects, acute or affecting quality or duration of life. Now, how to interpret and communicate the result? We have suggested the use of a multi-criteria table to facilitate the understanding, and how to consider variability and uncertainty. We tried to apply a second-order Monte Carlo simulation to have a quantitative approach. Thank you very much for your attention. My poster is in 66, and I would be very happy to tell you more about this subject.
Okay, thank you very much, Geraldine. Very, very interesting. I think I just saw the whole of the work that we do in EFSA in a very quick 3-minute PowerPoint presentation, so well done to her. And certainly go and have a look at the poster, and have a look at all the posters, not just the ones that are presented here tonight. Sorry, just to introduce myself, my name's Tony. I work in the communications department at EFSA. I didn't just walk in here and decide to pick up the microphone and start talking to you. So that was all about staying relevant. The next presentation is about the environment. It's in the environment area, and the presenter is actually a bit of a friend of ours. He's been around at EFSA for a while, but he comes from the Institute of Pharmacological Research, Mario Negri in Milan. Eduardo Carnesecchi.
Hi, good afternoon. So today I'm gonna present my research project on the development of innovative QSR models for human and ecological risk assessment of mixtures and emerging contaminants. So, as you probably know, around 2,000 chemicals are authorized on the EU market so far, and the current regulatory risk assessment scheme is mainly based on single substances rather than on multiple chemicals. Therefore, the combined exposure to multiple chemicals and the cocktail effects are raising concerns among scientists and risk assessors due to the huge number of chemicals involved, their toxicological profiles, and the many routes of exposure. From a risk assessment perspective, however, it is not possible to perform in vivo tests for all the chemicals authorized. Therefore, scientists have recently developed alternative methods and in silico tools such as QSR and the read-across in order to replace, reduce, and refine animal testing. So what are QSR models? Basically are in silico tools that allow predicting a property or activity such as an endpoint for a given chemical. In this case, the QSR is a mathematical model that can correlate the endpoint, such as LD50 or an oil, to the structural feature of the chemical by encoding it in a molecular descriptor that usually is represented by the molecular weight and several others. Therefore, once we have compound with known endpoint or property values, Then we can build our model. And therefore, the model can be used to predict external chemicals with unknown endpoint or properties. In particular, our project aims to integrate results from different in silico tools, starting from read-across techniques that allow predicting missing endpoints or properties by assessing the chemical structural similarity of chemicals. Similarly, the mode of action classification model identifies key fragments in order to assess whether chemicals act in a similar or a dissimilar way. And finally, we can integrate these results with a quantitative or qualitative assessment of binary mixtures thanks to regression model or classification models for testing for additive or non-additive effects such as synergism. Of course, all the results will be finally integrated within a weight of evidence approach that has been recently developed by EFSA in 2017. And this, we hope that will address the chemical mixtures risk assessment for the next years. I would like just to thank you for your attention, and my poster number is just over there, number 86. Thanks a lot.
Bravo, Eduardo. Grazie mille. Our next picture has come a bit further than Milan. The name is Simone Tosi from the University of California in San Diego.
Thank you for the introduction. So my talk is mostly about synergism. So animals, such as bees, are exposed to many different chemicals. And often it is even more likely that animals are exposed to multiple stressors at the same time, multiple chemicals at the same time. And this is a particularly critical issue, especially because we know that chemical mixtures can cause synergistic effects, reducing animal survival. This has been shown in many different studies, but there is still an important data gap about this issue. For example, what are the synergistic effects that can be caused on animal behavior? And is there any synergism that can occur when there is an interaction between pesticide and non-pesticide stressors, such as a nutritional stress? So in this first study, we demonstrated that it's possible to have adverse synergistic effects on animal behavior when we expose the animals, in this case bees, to binary chemical mixtures. And I don't have time to explain the graph here, but basically we used standard ecotoxicological tests to do this, and we refined this test, adding descriptions and videos, trying to standardize and increase the replicability of our studies in ways that it can facilitate the implementation for risk assessment. In this second work that I'm presenting tonight, we demonstrated that exposure to a nutritional stress, such as a nutritional deficit, and a combined exposure to a sublethal pesticide stress can cause synergistic effects and reduce animal survival. For example, a sublethal dose of a pesticide can become lethal when the animal is also subject to a nutritional stress. Thus, to conclude, we highlight the importance of interactive effects and how these are key drivers of bee health. However, these interactive effects are not really addressed in the risk assessment procedure, and that is also because there is an important data gap on this issue. And we are trying with our studies to fill this gap and thus highlight the importance and the relevance of synergistic effects for animal health. Thanks. My poster is, I think, 104 over there.
Thank you very much, Simone. Didn't sound like you're from San Diego, but I'm sure you are. So, how do you talk about something so small you can't see it? How do you know what happens to it? Our next presenter is Francesca Ferraris from the Istituto Superiore di Sanità in Rome. So she's going to talk about what happens to nanomaterials and also some work that they've been doing on in vitro studies. So how you can look at that with in vitro studies. Over to you, Francesca.
Thank you for the kind introduction. So this afternoon, I'm glad to give you an insight into risk assessment of nanomaterials used in agri-food sector. So in the food sector, application of nanotechnologies to agricultural production, food processing, and food contact materials are rapidly developing. Nanotechnology application may bring benefits, but what we have to exclude completely is the risk associated with the ingestion of nanomaterials, for example. In fact, when we ingest any kind of food with nanomaterials inside, two different scenarios can face. The first one is that the nanoparticles rapidly and completely dissolve inside human body. So in this case, no nanomaterials risk assessment is needed since there's no exposure at all. On the other hand, if nanoparticles persist as such after gastrointestinal digestion, they might be absorbed by the gut. And in this case, we need to assess the nanomaterials risk. This is what we want to do in the NanoPersist project, a project in collaboration with the European Community Joint Research Center. And we are trying to develop and set up a method to assess the risk connected to the ingestion of nanomaterials. So in the first phase, we will simulate an in vitro gastrointestinal digestion, sampling pristine material inside food matrix, and the material after the intestinal digestion at specific time points. Then we have to check if there's or not a clear decrease in the presence of particle over the time, and if more than 12% mass base of those particles is still present after 30 minutes of intestinal digestion, then we will pass to phase 2. The phase 2 is to mimic the lysosomal fluid in order to evaluate the real biopersistent and the biological fate of those nanoparticles inside human body. So all these methods of these phases are important because they are the basis for the risk assessment strategy for nanomaterials. And the validation and standardization of these methods is a priority research needed since, as I told you before, several and huge range of nanomaterials of relevance is used in the agri-food sector. So the last things I just wanted to tell you is that for the physical-chemical characterization, we use a multi-method approach made by mass-based and not mass-based techniques. My poster is the 13, so for any kind of question, I will be glad to answer to you. Thank you for your kind attention.
Thank you, Francesca. So now we move from something very small to something very big, biological hazards and emerging zoonoses, and we move from Roma to Spain. And our next picture is Alberto Gare from the Technical University of Cartagena.
So thank you for the introduction. Yes, so this work is about choices. That choices are an essential part of our life. For instance, you have just decided to be here listening to me rather than having a coffee or a beer. And of course, choices have to be made also in food science. Food industry may have to choose between different alternative technologies, or we may have to, or also between different quality systems. And these choices are hard because of many different reasons. For instance, we may have to take into account different factors, and these factors may have may be different to combine. For instance, how do we combine the probability of transmission with the possible economic cost that something is going to have? And on top of that, we have to take into account uncertainty and variability that are very relevant for the food industry. So then, this is something that has already been presented this afternoon by the speakers, and is that food science is a very sensitive topic, and we need to have some robust statistical methods or algorithms for making these decisions. So what we we explored what are the possible ways of doing this, and then we saw that there is a methodology that is named multi-criteria decision analysis, and it's a very general methodology for making decisions and ranking alternatives. So there is a big a set of algorithms that are already available, and many of them are already able to take into account to model this uncertainty and this variability. However, there is no clear guidelines on what's the best algorithm and then what algorithm is going to be better for a given problem. So then the selection of the algorithm for the decision making is already a decision making problem on itself. So then we wanted to evaluate how this selection of the algorithm affects the results on a food safety problem. So then we took this article that was published by Havelar and collaborators, which is about prioritizing emerging zoonosis in the Netherlands, and it was published in open access, and the data set was made available openly. And then so they were taking into account seven different criteria that were very different units, so it fits well this definition. And then we wanted to see, well, if the selection of the algorithm affects the solution. So here we did all the calculations, and here we are comparing the results, and if all of them were the same, all these lines would be straight, like, for instance, this one here. So then we can see that the selection of the algorithm does indeed affect the results. So this selection, it has some uncertainty associated. So we were thinking about how can we reduce this uncertainty, and what we proposed is to apply a hierarchical clustering, that is this thing here. And then this is putting together, combining the results of all the different algorithms. And then, yes, so then this is therefore a more robust option. And then also it could reduce the uncertainty of this selection. So, well, and just to conclude, this approach we have applied to this problem, but it's a very general approach and can be used to any multi-criteria decision analysis problem in principle. So yes, so my poster is somewhere over there, number 145, I think. So any questions and suggestions are welcome.
Thank you, Alberto. Very interesting. So it's getting close to dinner time. My tummy's rumbling, at least. So it's interesting that the next presenter is going to look at nutritional advice, dietary recommendations, and also how mathematical optimization can help with that. I'd like to invite up on the stage Maria Persson from the Technical University of Denmark.
The food authorities in Denmark recommend an intake of 350 grams of fish per week, of which 200 grams should be fatty fish. However, the majority of the Danish population do not meet this guideline. Actually, only about 15% of the Danes meet this guideline value, and the variation between individuals is very large. Some people don't like fish and don't eat it at all. Some people eat a lot of fish, and quite a lot of people eat a little bit of fish. And knowing this, I think we all can agree that this guideline value in Denmark is not very effective. And this is why you should come and check out my poster. Because on my poster, I present a method that's generated for generating personalized recommendations. What we assume is that personalized dietary recommendation would be perceived as more relevant by consumers, whereby motivational effects will be increased. And this will hopefully lead to a higher compliance to the recommendation. And this is all due to the fact that personalized recommendations can take personal needs and personal preferences into account. So the aim behind my work is to propose personalized fish intake recommendations that account for personal preferences, and at the same time, they meet recommendations for EPA, DHA, vitamin D, and at the same time, they do not violate tolerable intake levels for methylmercury and dioxins. And when I talk about personal preference, I mean observed intake. So the whole idea behind this is to use intake data from a population and starting with that as a starting point, generate new recommendations that deviate as little as possible from these intakes. And really shortly, before wrapping up, I want to show you the method in a nutshell. What goes into the method is individual observed intakes along with body weights for 3,000 Danes. And then what the model does is that it minimizes the deviation from the individual observed intakes subject to the nutritional and toxicological constraints that I mentioned earlier. And what then comes out of the model would be personalized recommendations that fulfill constraints on nutrients and contaminants and at the same time deviate as little as possible from the observed intakes. Thank you so much for your attention, and I'm happy to take more questions at, I don't remember the number, 191, I think? Yeah, okay, thanks.
Thank you, Maria, thank you. So, our last picture, that's right, isn't it? Yes, so our last picture tonight, but we'll be here again tomorrow and on Thursday at the close of the last session. I want to congratulate all the pictures, exemplary, all kept within the 3 minutes, all very clear. You don't need 50 slides and 45 minutes to do an effective PowerPoint presentation. So congratulations to everyone. The last speaker, we've heard a lot today about GMO, we've heard a lot today about public participation, societal concerns, we've heard a lot about risk communication. Our last speaker is going to bring all these three things together in one pitch, which will last 3 minutes. And he is Ayrton Andre Rosada Juanashi, I hope that's correct. He's from the International Centre for Genetic Engineering and Biotechnology, which has 3 centres, Trieste, New Delhi and Cape Town. I'm not sure which one you're from, but...
Thank you.
Andre.
Thank you, thank you. Thank you for having me, and thank you for the introduction. Yes, I'm Andre from the International Center of Genetic Engineering and Biotechnology, and today I'm going to talk to you about some risk communication activities that we do, and also that are related to public participation into the GMO decision making. So, first of all, please be aware that countries need to establish biosafety regulatory systems in order to regulate the use of GMOs around the world. So, in most of such systems, countries tend to have the requirement to include the public participation. So, therefore, countries tend to establish different strategies in order to develop such mechanisms in order to include the public participation into the decision making. However, in many countries in the developing world specifically, they still lack such mechanisms. Therefore, here is where ICGV enters. We tend to provide technical assistance on risk communication and also other issues, but specifically now that I'm talking on risk communication, in order to discuss and develop different strategies in order to support public participation into the GMO decision making. So, the content of such training activities that we tend to use focus on 5 features, the ones that are in here. Just to let you know, in the meantime, my poster is in that direction if you are looking forward to find more information about what I'm saying now. If you don't understand me, I'm sorry for talking too much and too quickly also. 5 features, okay? So there are basically 5 keywords that I would like you to remind. There are stakeholder groups, provided and collected information, communication channels, and also suitable messages. Those are the 5 elements that we always tend to consider when we tend to do these training activities in developing countries. For more information about those 5 elements, please, you can come to visit my poster, and for sure I will give you more examples and details about that information. Something that I would like to say that it's something that I think that we already hear from previous sessions during this day is that, well, I would like to say it in my own words. The public is going to accept that decision, or is more likely to accept the decision if such decision has been taken with wider public inclusion. If you are more interested to know about more information about risk communication, please be aware that this Thursday there is a breakout session called Engaging with the Society. And also, if you would like to hear more about information about what I'm doing and also in the ICGV, please remember that my poster is in that direction. Thank you.
Hello. Thank you, Ayrton. So just to close things off, just wanted to remind you to you can vote for the posters on the app. Make sure have a look at all of them. In a way, our presenters this evening and tomorrow and the day after are at a bit of an advantage because, of course, they've got your full attention. So please make sure you look at all the posters and really try and vote for the one that you think overall is really the one that brings together everything in the best possible way. So from me and my co-presenter Simon, thanks very much for your attention. Thanks to the presenters, and we'll see you here again tomorrow at 5:30 for the next round. Okay? So thank you very much. Enjoy the posters.